Okay, we want to create a GDML simulation solid for this double-ended collet holder that looks like it's going to fit inside of a lathe sleeved holder for a turret. And when it comes in, this is a product from Pioneer Tooling. And if you wanted to follow along, you can go to their website and directly download the step file for this model. Any of the straight shank, double-ended, collet holders is going to be fine. They're all basically, slightly different collet sizes or lengths. So when we read this in, we can see the center of the model is located at the 0 point. And what we want to do is align this unit so that it's aligned along the z-axis, this blue z vector. So I'm going to go ahead and pick this face of one of the collets, doesn't really matter. And then I'm going to come up here, and you see under manipulation, under the manipulation tab, we have the align x, y, and z. And I'm going to hold my shift key as I click on the z. And when I do that, you see that we get the solid oriented along z, but with the z vector pointing into the solid. So we can get one of two results. If we do not hold the shift key, the blue vector would be pointing the other way. It would be normal to this face, going out away from the solid. But going into the solid, you want to hold the shift key. So we're going to set that up this way. And so if you've been making some GDMLs and familiar with this process, why am I thinking in my head I want to do this? Well, if I set this as my 0 point, when this appears inside of my digital twin, so let's say there's a lathe holder here. This will be my 0 point and flush with that front face of the lathe holder. And then whatever I set for my Z extension on this adaptive item, I will have that number as the exact physical stick out or overhang or whatever you want to call it from the face of this collet to the face of the turret block, wherever that would be. So I'm setting this here so that I could use that number to control very easily what that value would be, and I would know it very easily. So I'm going to go ahead and also just pick a couple of or both of the collets on each side, and I'm going to come here, and I like to use black and then change this to kind of like a 80-80-80-ish, so you can see that it kind of looks like a real product. And what I'm going to do is I'm going to set my tool position here as well. So I'm going to do TA_1, and I'm going to come to modify work plane and pick my Z vector and kind of rotate this around and just move my mouse till the highlight of the center of the other face is created. And then what I'll do here is use my rotate UVW and do 180 about U, 0, 0, so it flips my vector around. And then I'm going to come in here and say TA_2 and click elsewhere to make sure nothing is highlighted, and then just save this as a GDML file. And you can save it wherever you want. So here for me, I am going to just put it in where I normally put it. And we can go ahead and take a look at the simulation for how to use this. Okay, so here we have a machine. It's got some Hymatech and some MT tooling on it. We're going to go ahead and look at this guy here. So what we can do is right click and say add an adaptive item. And just looking at that, assuming the sleeve size is okay, we'll come to holders and then go to Pioneer, go to straight shank, and then we'll look at one of those ER collet, double-ended collets that we were making, such as this one. You can see the preview. We'll say open, and we can see that where it appears is at the front, it's flush, with that front face. So now, we have that z vector, so I can translate x, y, z here. I've got an x, a y, and a z value. So if I put in -2 inches, we can see that that collet holder is projected outward. Let's go to 1.5. That would look a little bit more appropriate there. So we can see there that I can extend that collet, and I'll know, if I put my calipers on there, I'll know exactly where I'm at. I've got that 1.5 inch value right there. And because we created our tool, the tool adapter position at the front of the tool, what we can do here is just set some, what is this? Is this an inch file? Yes, it is. We'll set this to 0.5 and 0.5. That is way too big. So we can see here that, our tool is going to come in the correct position. So we can just set this to, some numbers that would actually work here. And there's our tool. So, if you wanted to have a tool on the other side, because we created the TA2, you can do that as well. We can right-click and say, add another milling tool. If I add another milling tool here, it's automatically going to, use the next position, which is the only free position. And, if I wanted to make this a 1/8, we can do that on that side. And we can see that very quickly I can build nice collision checking inside of my digital twin using the new Pioneer double-ended ER11 collet holder that we just made. So hopefully this helps you guys make some nice looking and very accurate for collision checking digital twin simulations in Esprit. Stay tuned for more helpful videos.